So if you look at the back of your flip chart, everything that I wrote here in black was already written on your paper. We're going to add some information here to the card, and what I have written in red is obviously something I want you to include as well. Like the letters at the top, A, C, B, and H, those should be capital letters. Those are points on the triangle. And if you remember, I should have probably also added this as well. I think it's on yours. This is a right triangle with an altitude. And we dealt with this picture quite a bit last class, and we talked about some of these segments were geometric means and how does that relate to the proportion and all that kind of thing. And so it's not really step 1, step 2, step 3, but it's the 3 different cases, would you agree, for our triangle here. We know that H is a geometric mean. The length H, which is a small letter H, it's a geometric mean between little x and little y. We did that last class. We know that little a, which is the segment over here, it is the geometric mean between the part of the hypotenuse that it touches, which is y, and then the entire hypotenuse, which is c. And then b is a geometric mean between x and c.
Couldn't it touch B2?
Couldn't what touch B2? Part of the hypotenuse that it touches. H is not the hypotenuse of the large triangle. Okay? Remember how I drew this last time and I said it was kind of like a, I don't know, I said I drew that like arc around it. And A is the geometric, you're not even looking at me, India. Why am I even answering your question? Come on. A is a geometric mean between the part that it touches and then the whole thing. So I kind of drew that arc around on purpose so you knew which direction to go. Okay? Yeah, I called it the banana method. It's just because it looked like that. I even used yellow, right? Yeah, exactly. Same kind of thing. All right, so I want us to add some information to our picture here. I want you to take one of your colors, and on the triangles, I want you to highlight the hypotenuse of each triangle in one color. Okay? So pick one of your colors and just choose and find in your big, small, and medium. And we actually did this with a note card last class where we actually cut it out. We ended up flipping one of them over to create the 3 similar triangles. And I want you to highlight the hypotenuse in one color. And then I want you to pick your other color, and I want you to highlight the long segment. Okay? So if you look at the big triangle, which segment is the which leg, not the hypotenuse, but which leg is the longer one? Isn't AC the longer one? So I'm going to highlight AC in one color. If I look at the medium-sized triangle, which is this guy right here, I'm going to erase this in just a minute, which segment is the long leg? AH. Okay, so I'm going to highlight AH. Notice it's rotated, and that's okay. And then how about the little triangle, which is this guy right here, which segment is going to be its longer leg? CH. Okay? There's a reason why I'm having us do that. Because I want us to write the congruent statement, triangle ABC is similar to which triangle? I want us to write kind of an extended similar statement. And using the colors and what we've highlighted, I want us to figure out what corresponds to what. So if the big triangle is triangle ABC, what would the medium-sized triangle be? Well, if you look at the big one, the big triangle, A is the intersection of the blue and the yellow. So what point is the intersection of the blue and the yellow here? Well, it's also A, so it starts with A. But then, what is the order? It's not AHC. It's actually ACH. Because AB is the hypotenuse, and so is AC. Does that make sense? So AB is the big hypotenuse, AC is the medium hypotenuse. So I have to make sure I'm writing these letters in corresponding order. How about over here? Give me a second to catch up. Think about the small triangle. What is going to be the order of those letters? It's going to start with C, I agree, and it's going to go C, B, H. Very good. Okay. So this is kind of like a little bit of a review of what we did last class. It's on your flip chart, so you have it there. But I want us to now, are there any questions on this first before we go any further? I know Emma wasn't here last class. You got some catching up to do, but you will. Anything else that we can clarify or not sure about? We good? Okay. The next part I wanted us to look at were these 3 note cards that you're going to attach to the other side of your flip chart. And I went ahead on mine and I highlighted angle, angle. I highlighted side, angle, side. So I took one of my highlighters and I just went ahead and highlighted this so it kind of stands out a little bit. Okay? And again, you are going to cut the bottom of that note card off, the last one. So if you need some scissors, I've got some for you. You can borrow those if you want. You can do it at home. A lot of you didn't bring note cards today. That's okay. You can tape them later, however you want to deal with it. So these are the pictures. What I'd like us to do is I'd like us to add some information to these pictures. Okay, I'd like to label these triangles with the following letters. These are the actual ways to prove that triangles are in fact similar. Okay, so we are going to be moving on now to proving that triangles are similar. So thus far, we've always been told that they are. We can test to see whether they're similar because if they are, all their sides are proportional and all of their angles are congruent. So we've kind of already done some background work. If the triangles have all the same side, or all the sides have the same ratio, and all the angles have the exact same measure, then we know they're similar. These are like 3 shortcuts, okay? We don't have to prove all the angles are congruent. We don't have to prove all the sides are proportional every time. These are the 3 shortcuts to proving that triangles are similar. Notice that side, angle, side, and side, side, side were also ways to prove triangles were what? Congruent. It's a little bit different here, though, okay? Let's start with the angle, angle, and I'll show you why these other 2 are a little bit different. First thing is when you look at this, how many triangles do you see in your angle, angle picture? I do. I see 2. A small one up at the top and then a large one down at the bottom. Do you agree? Sure it is. Triangle ABC is a triangle, and it's going to actually be similar to the small triangle at the top. By angle, angle, and I'm going to show you why. I do need to tell you that these 2 sides are going to be parallel, though, okay? So make sure that you're adding that parallel to it for me, because that's an important piece. If I have parallel lines, what kind of angles are going to be congruent? Alternate interiors, which is what we've used before, but I don't see any alternate interior angles. What kind of angles do you see? Corresponding. This angle and this angle are actually congruent to each other. Because if the lines are parallel, then corresponding angles are congruent. We can actually say the same thing about angles BED and BCA on the right-hand side. But I'm also going to say, don't these 2 triangles share an angle? Reflexive property, right? They both share angle B. So because the small triangle has 2 angles, the big triangle has 2 angles, they are in fact similar. Some textbooks call this angle, angle, angle. Why is the 3rd angle not necessary? Not because there's 2 triangles, but, Marvin? Right. If I have 3 angles in a triangle, and I already know 2 are congruent, doesn't the 3rd one have to be, just kind of by default? Because all of them add up to 180 every time. So it's enough information just to say angle, angle. You don't need to do the 3rd one, okay? So let's finish our similar statement. If I have triangle ABC, what's the smaller triangle that it's similar to? D, B, I can't hear you. Thank you. Sorry. DBE. Good. Okay, so I want you to add that information to your picture. So if I'm only talking about angles, notice I don't know anything about the sides, do I? Don't know anything. And I don't need to. I do know now the sides are proportional. I don't know what the scale factor is, but I do know that they are proportional. If you look at a situation like side angle side, I want you to add this information to your picture. Okay? I want you to say that this side is 4, this side is 3, this side is 6, and this side is 8. So add that information to your picture. So now I am given some information about some side lengths. So Maddie? So if we look up here, notice I'm looking at the position of the angle. I know something about some sides. We'll get to that in a minute. Do I have any angles that happen to be congruent? Because we know that in similar polygons, angles are congruent, sides are proportional. So do I have congruent angles? Yes. I've got vertical angles. Excellent, Brittany. So I know that these angles are congruent because they're vertical. Okay, that's good. Is the angle the included angle between the two side measurements that's given to us? Yes, so that's good because we want it to be the side angle side. I do need to test the sides though. I need to say, and this is what I would do on the back side. I would say, is on the back of your note card, you're going to say, is 4/8 the same as 3/6? Is that a true statement? Yes, because you're going to reduce each of those, right? They reduce both to the same proportion, do they not? So the sides are proportional, and that's what you need to say. The sides are proportional. So since the sides are proportional, are the triangles congruent? I'm not congruent, but they are similar. So we're going to say triangle QRS is similar to which triangle? We have to write it in corresponding order. TUS. Very good. Excellent. So again, do I know what the scale factor is in this case? It's 1 to 2, isn't it? Okay, or 1/2. So I do know the scale factor here. Didn't in the first case. Don't really care because I don't know the side measures at all. I would have to check for the scale factor in the second one. And then the third one, I'm not going to know anything about the angles at all. I'm only going to know about side measures. So you'll need to add this information to your picture as well. This one's going to be 3, 4, 5, 6, 8, 10. Okay? Well, you write what I wrote underneath it. So you write what's in green and in red. So on the back of this one, you're going to need to do the same thing. We're going to have to test that the sides are, in fact, proportional. So how do I know what side corresponds to what side here? If I was given a statement, yes, but I'm not. What do you suggest I do? I know you know the answer. You're just not putting it into words. This side 3 is going to correspond to what side in the other triangle? How do you know that? You know it's got to be 6. Why? They're the smallest. Don't small ones correspond, middle ones correspond, and big ones correspond? So you know that already. It's intuitive. You've already kind of understand that part. So when we write when we're testing to see whether or not they're congruent, we're writing our proportion, you're going to say 3 is to 6 as keep going. 4 is to 8 as 5 is to 10. Do they all reduce to the same number? Now, I picked numbers that all reduce to a half. Is the scale factor always a half? Of course not. I just happened to pick that in my example. Shame on me. Okay? So since they all reduce to the same number, the sides are proportional here as well. Okay? So there are 3 ways to prove triangle similar. And these are your 3 ways. Angle, angle, side, angle, side, and side, side, side. Okay? So keep this little flip chart off to the side for me. Okay? And if you would, go ahead and open up your packet. And in it, you will find this page, right? I think it's right on the back of the geometric mean. It says 7-3 practice. Do you see that? You might, to test the sides proportional. So go ahead and look for this page for me. It should be right in that packet that I handed back to you from homework. And I'm going to go ahead and pause the recording. I want you on 1 through 6 to make a decision. Are they similar, yes or no? If they are, I want you to tell me how you know that and by which method. Angle, angle, side, or side, side, side. Remember, with similar triangles, you only have 3 choices. How many choices did you have with congruent triangles? You had 5. Okay, so we have fewer choices to pick from. So go ahead and think about it for yourself for a minute, and then we'll go on from there. Okay, so just 1 through 6 here for now. So I agree with your sentiments that 2 and 4 were not similar. Okay, we don't know enough to say that they are. If you actually look at number 2, am I given enough information at all? I'm only given 1 pair of sides. They're actually marked congruent. That's fine, but I would need another angle. Or I would need another side, actually. I would need side, angle, side. Okay, let's start with number 1. I know nothing about the sides. So what's the only possibility of them being similar? AA. Very good. So let's mark what I do know. Okay? What do I know? I know, do I have some vertical angles? Do I have some parallel lines? All right, so let's mark what we know is congruent to each other. What is it? Okay. How many angle E's are there? 4. So don't say angle E. Okay. I see AEC, AEB, BED, CED. I see 4 angle E's. AEB is congruent to CED. I agree. Vertical angles are congruent. Perfect. Still not enough. I'm given some parallel lines, so I can use which theorem? Am I using the corresponding angles theorem in this case? No. I'm using the alternate interior angle theorem. And I could say that this time angle A is congruent to angle D. Good. I could say the same thing about C and B. But they are. So let's write our similarity statement. Triangle AEB. Now if you wrote yours in a different order, just make sure it corresponds. Yes, sir. In theory, that's true, but because it's not an intersection point like E is, we can go ahead and just use it as angle A because it's just 1 in the triangle, right? All right, so angle AEB, and what does A correspond to in the other triangle? So it's going to be DEC, and the reason would be angle, angle. Very good. So that's kind of what I was looking for in terms of the work for this problem. Looks to me like most of you got that. Number 3, Eliodoro. Give me something I know about those angles. This picture should look oddly familiar. What do you think, Eliodoro? Good. I had the reflexive property here. They share angle N. The big triangle and then the little triangle. One just happens to be inside the other one. Okay, that's okay. Good, so I know that's to be true. Give me something else I know, Andrea. What else do I know here? Do I know anything else? I actually do. I can use the parallel lines. Go ahead, Deshay. Okay, so we'll say M and NPO to be specific, right? So aren't those two angles congruent? What's the reason, by the way? No. No. You're just like throwing, you're just like, yeah, diarrhea of the mouth. No. Okay. The reason I know these angles, not triangles, but the angles are congruent is because if the lines are parallel, then corresponding angles are congruent. Good. So why is triangle LMN similar to triangle, keep going, what was LMN? What does it correspond to? OPN. Why is that true? What's the reason? We still have angle, angle again. Good. Which is what I think India was trying to say. Okay. All right, we have two more down here with 5 and 6, but this time we're given some side measures, so we are going to have to do some testing. If you look at number 5, which one am I looking at choosing? Side, angle, side, or side, side, side? One more. Side, 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 or side, angle, side? Side, angle, side. Do I have an angle that's congruent to each other? Yeah, the right angle. So we know all right angles are congruent, right? So that's good. What would 28 correspond to in the other triangle? Because it's the bigger one, right? So 28 is to 14 as 10 would be to 5. Do those reduce to the same number? Yeah, they're both 2's. So the sides are proportional. I've got the angles congruent. So therefore I can say that triangle TUV, and again, if you didn't write it in that order, as long as it corresponds, that's okay. So TUV would correspond to UWX by side, angle, side. Without this work, folks, I would mark it wrong, just so you know. If you are going to be using side, angle, side, or side, 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 you must show me the proportions and that the ratios are the same. Okay? So that's required work. Okay? You can't just say that you know it. I put it in my calculator. Well, good for you. But you know what I'm saying? Like, you have to be able to actually show me. All right, let's look at 6. What am I thinking, Ryan, as the reason that these triangles might be similar? Is it going to be angle, angle, side, or side, side, side? I got to know all about sides. I know nothing about their angles. Well, sort of. I kind of know something. Aren't they? What kind of triangles are these? Isosceles. So I know something about the angles, but not that they're congruent. All right. So since I'm thinking side, 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 let's write an extended ratio. I'm going to do it 3 times here. Maddie, start us out.
26 and 13.
Keep going.
30 and 15.
Keep going.
6 and 13.
Good. And we want to check to see if all these sides are proportional. Divide them. Are they? Happens to be 2 again. Okay, it's not, it's just a coincidence. But the sides are proportional. Question.
What if you like flipped it and you got 1/2 here?
Well, because we're going from left to right, I need to go for always when you read it like a book, from left to right. So it's the bigger one, then the smaller one. Remember how I told you that I don't like that because that's the way the state of Virginia makes you do it? Remember, did I ever tell y'all it made me uncomfortable? No, I think I did. But anyway, you always read it from left to right. Okay, so you always go from this case big to little.
Isn't that how you read a book anyway? I'm sorry, I don't.
That's true, you do read Japanese backwards. All right, so the sides are proportional, so let's write our statement here. I know that triangle NML is similar to triangle. We have to be careful here. One's upside down. All right, Sharia. What do you think? What does N correspond to in the other triangle? Huh? O would work. Is there another letter it could work? P would work too, either one. okay? Because if you notice, it's in between both 26 and 30. O is in between both 15 and 13. So either one would work. So I said O is fine. And then it would have to be Q. So OQP. It also could have been PQO. I would have accepted either. And that reason would be what? Side, side, side. Very good. Excellent. Good. Now, as you guys know, let's finish this first. Sometimes, always, and ever. These are always popular quiz questions, aren't they? Let's read these. Similar triangles are congruent. Always, sometimes, or never. Similar triangles are sometimes congruent. And what would the scale factor have to be? Good. Sometimes, when the scale factor equals 1. How about down here? Congruent triangles are similar. Sometimes, always, always. Very good. They're always similar. Excellent. All right, so this, oops, not this one. Here we go. I think this is on your paper, isn't it? We're going to need to create some statements and some reasons. So you need to write this on your paper as your notes, right underneath the picture. Statement column, reason column. Prove, hence it says given and prove. Okay? Proofs aren't going away. So we kind of already have everything we need to know in our repertoire. Another word that India probably is going to ask me what that means, right? Did I already say that word in this class before? Okay. Do you know what it means now?
No. I thought it
Hopefully.
was like a drawer. like an armoire.
A bureau. Have you heard that word before? Bureau for a chest of drawers? It's not a common word. It's an old lady word, bureau. And it was on the SOL in like 3rd grade. And then how would a 3rd grader, it's not a common word. Anyway, it was interesting. Whatever. I'm going to tell you that this proof, I believe, has 3 or 4 steps. I believe. Let me count in my head real quick. If I put all the given in the middle, or I'm sorry, all the given in the first statement, then it is 4 steps. So let's set up what we know. We know that we can write all of our given information here. Actually, I believe it's going to be 5 steps. So perpendicular lines form right angles, and then you have to say that all right angles are congruent. So it's actually going to be 5. My bad. What's the first reason? Sharia, what is it? What's always my first reason? Given. Throw it out there. Do I ever have a proof as a reason? If I ever see the word prove as a reason on a proof. Ah, most frustrating thing. Never. Prove is never a reason. What's my last statement always? What's my last statement? What I'm asked to prove. In this case, it's going to be triangle RSM is similar to triangle STN. Okay, that's good. So now I've got to fill in the blanks. I know that I have one of 3 choices for the 5th reason. And by the way, we need to add those 3 reasons to our reason sheet, and we'll do that in a minute. It's either side, 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 angle, or angle, angle. Do I know anything about any side measures here at all? Maddie and India, I'm going to separate you, and one of you is going to be in the back of the room. You need to be paying attention, writing down what I'm writing down, and stop talking to each other. Do I know anything about the side measures here? No. So what's really the only possibility for the reason that the triangles would be similar? So that's really the only reason, angle, angle. Let's see what else I can fill in. I've got a pair of parallel lines here. Parallel lines. Don't I know that those 2 angles are congruent? What kind of angles are they? They're corresponding angles, actually. So if the lines are parallel, corresponding angles are congruent. So we're going to say that angle MRS is congruent to angle NST. Because I have some corresponding angles with parallel lines. Two parallel lines cut by a transversal. Okay. Now what? Well, I've got some perpendicular lines too, don't I? I have RM is perpendicular to MS. Correct? What do perpendicular lines form? So perpendicular lines form right angles. Therefore, we need to say the fact that those angles are right angles. So angle RMS and angle SNT are right angles. It takes 2 steps for me to get from perpendicular to angles are congruent. I first have to say that the angles are right angles. Then I can say all right angles are congruent. So I'm going to say the congruent statement. Angle RMS is congruent to angle SNT. Therefore, the two triangles are similar because angle. Okay. We will come back to the next problem that has the coordinate geometry on it next class. Okay? So you're going to need to keep that there. Okay? Your homework is going to be out of the textbook, and it's going to be here, page 455 to 457. You will have a couple of proofs. You need to set them up and do your best at filling them out. And then you have some identification issues, just like we did in class. Okay? Okay?